So indirect or inverse proportion is where as one quantity increases, the other one decreases, or vice versa. So an classic example is speed and travel time. They are inversely proportional because basically, like these 2 points here, as the speed goes up, so as it gets faster, the travel time actually goes down, so it gets shorter. Or vice versa, as the speed goes down, so as you get slower, the travel time takes longer. So they're going in opposite directions. So similarly to our direct proportion, we have a relationship between two quantities, but this time, instead of it just being related in terms of the value of x, it's 1 on x to make it to cater for the inverse proportional rate. So we have the constant over x. So let's have a look at an example. If we've got 4 people painting a fence in 3 hours, and let's just assume that everyone's working at the same rate, how long will it take 6 people? So we know the time's has to get shorter because there's more people doing the painting. So that's why it's an inverse proportion question. So I've just set it up. So I've let t equal the number of hours, k is our constant of proportionality, and our n is our number of people. So once you set up your pronumerals that stand for the information of the question, you set up your equation. Now subbing in what we do know, and that is that because 4 people can paint the fence in 3 hours, our time will be 3 and our number of people will be 4. Putting that in, then multiply the 4 from the denominator across to the other side and you'll get k equals 12, and then put that 12 back in the equation. So instead of the k, we now have 12. So the time equals 12 divided by the number of people. So now the question is asking when you've got 6 people, so you substitute your 6 in and do your division, you get 2 hours for the fence to be painted. If I wanted to do the same kind of painting of the fence, but I wanted the job to be completed within half an hour, you just set up your equation and you make your time half an hour. Then you can just cross multiply. So if you times your n over there, you've got 1 lot of n, times your 2 over here, you've got 24. So that's how you get 24. So it needs 24 people to actually get the job done in half an hour. Okay. Next example, if we've got 10 harvesters, take 12 days to complete harvesting of a property, how long would it have taken 15 harvesters? So I'm just going to go over here to this inverse method that we were doing first. So I set it up as t for time and h for number of harvesters. So putting in the information that we know, we have 12 days and we have 10 harvesters. Then multiplying the 10 across the other side, and we get our constant proportionality of 120. Put that back into our equation, and then you go, okay, how long will it take for the 15 harvesters? So divide by 15 and you get 8, so it will take 8 days. Another method you can do is think about it as how long would it take one harvester. So you'd multiply the 12 days by 10, so it would take you 120 days. And then for 15 harvesters, you would be dividing it by 15 to get your 8 days. So it's another way of thinking of it. The next example is if you travel at a speed of 50 kilometers an hour, taking 4 hours to get home, how long will it take if I go on an average speed of 60 kilometers an hour? So we know that because that speed's faster, our time will get shorter. So it's inverse proportion. So I've set it up as time equals the constant proportionality over the speed, putting in what we know, so our 4 hours at 50 k's, multiplying the 50 over to the other side, and you get your constant proportionality of 200, putting that back in the equation, and then you can solve the equation for when the speed is equal to 60, subbing in here, and you get 3 and 1/3, and 1/3 of 60 is 20, so that's why it's 3 hours and 20 minutes. The unitary method version, you can think of, well, 1 kilometre per hour speed would have been 50 times 4, so it would have taken 200 hours. So to get at 60 kilometers an hour, we're dividing our 200 by 60, and you get 3 1/3, which is the same answer. So just so you can see the other method. Just as another example, you can, this is back to direct proportion in this particular question, but you can do inverse or indirect proportional questions that are related to squares, cubes, exponentials, or different functions. Okay. So here's an example where we have a stone dropped from the top of a tower, and the distance it falls is proportional to the square of the time. So setting that equation up, I'll let d equal distance and t equal time, and then going d equals the constant times the time squared. Okay, and then replacing, because it says it takes 19.6 meters to go the 2 seconds, so that is our 4 times k, so dividing the 19.6 by 4, and you get 4.9. Putting that back into the equation up here, and so this is our formula then. And then you can find any missing parts of a question given one of the variables. So this one's asking for when time equals 3, so you substitute the 3 in for t, and you get 44.1 meters. Yeah, so it's fallen 44.1 meters after 3 seconds. So just an example, I'm not going to go through a particular question, but just so you can see, one of the areas where inverse square would happen is as the distance increases away from a light, the brightness decreases. So, and that usually does it in terms of a squared function as well. As you can see here, the intensity is like the area of the space where it is very intense is 1 square, and then you've got 2 squared, so its intensity is 0.25, and so it's going down like that. Okay.